Today we're going to be talking about the fundamental theorem of calculus part 1. Now the naming convention for which one is part 1 and which one is part 2 does vary by class and textbook. I will stick with what you're doing in your class, which is the derivative of an integral is part 1. So the way it is typically taught is there is a constant in the bottom and there is an x here, and whatever function I have here, because derivatives and integrals basically are sort of inverse functions, then these will sort of cancel out and give you f of x. Now this is how it's initially taught, but by no means the one that you should use, because in general the formula could be a little more complicated if this is a function of x and this is a function of x. So in general, if you have a derivative of an integral and the bottom bound is a function of x and the top bound is a function of x, what you end up with is you plug in the top bound in for your variable of integration, t in this case, multiply by the derivative of the top bound, minus, plug in the bottom bound, multiply by the derivative of the bottom bound. This formula is derived from, so we're going to derive the formula, but you're not actually going to need to derive it, you're just going to need to apply it in problems. So just as a quick derivation, if I start from this point, let's say capital F is the antiderivative of lowercase f. So the derivative of this integral gives me the antiderivative I still have a derivative on the outside. So I plug in the top bound, minus plug in the bottom bound. And now the derivative of these functions, you have to apply chain rule because you have an embedded function. So it's the derivative of the outside function with the inside unchanged times the derivative of the inside function. Okay, and so that's how that works. Now how do we actually apply it? Well, let's say I have something that looks like this. I don't need to know what the antiderivative is of sine t cubed. Instead, what I basically do is go ahead and apply the formula. So I plug in the top bound, multiply by the derivative of the top bound, which is 1, minus plug in the bottom bound, multiply by the derivative of the bottom bound, which is 0. Again, I could have used the simplified version up here. However, I do want you to, in general, always think in terms of the general case. A more complicated example, say the derivative of going from, let's say, sine x to x cubed of the square root of t squared plus 1 dt. Okay, so what I would do, again, I don't need to know the antiderivative of this. Plug in the top bound, multiply by the derivative, minus, plug in the bottom bound, multiply by the derivative of the bottom bound. And that's it. Hope that helps.